5.2. Without using a calculator, determine the value of sine squared 35 minus cos squared 35 divided by 4 sine 10 cos 10. So we can see a lot of things that look very similar to our trig double angles that we are normally used to. So what we need to do is, we don't have a sine squared minus cos squared, but we can modify this expression to make it a cos double angle. So firstly, let's factor out a -1 at the top to get a cos squared minus sine squared, which enables us to use our cos double angle, which is cos 2a, or cos 2 times 35 in this instance. So here at the top we will get minus into cos squared 35 minus sine squared 35, and that allows us to convert that into cos 2 theta. And then at the bottom, what we do have is we have 4 sine 10 cos 10, and our sine double angle is normally 2 sine theta cos theta. So what we can do is we can make it 2 times 2, so it will be 2 into 2 sine 10 cos 10, and that enables us to use our trig identities in these highlighted places. So once doing so, we can therefore conclude that the top is therefore becomes cos 70 or minus cos 70. In other words, since that is a double angle there, so here we can conclude that this is cos 2 theta, which is cos squared theta minus sine squared theta, comes from your data sheet, and this part here is sine 2 theta is equals to 2 sine theta cos theta. So then at the bottom we have our 2 on the outside, so that becomes 2 sine 20, and thereafter what we have is, what we can do is we have some co-ratios, and the reason why we have co-ratios is we have a cos 70 and a sine 20, and if we were to add these two numbers together we get a 90. So what we can do is we need to get rid of one of them, so essentially those two equal the same thing, but you can't just cancel it out. So we'll either have to change the top or the bottom. So we change the top to sine 20 or change the bottom to cos 70. So what we can do is we can say minus cos 70 divided by 2 cos 70, and then these two cancel each other out, and we are left with minus half.